Now let's look at the example of a paint filling system. Now there is this paint filling system that is designed to start filling the paint in the tank. So you see this tank? There is this tank over here, which is holding this yellow colored paint. Huh? And the paint filling system does that, or what this paint filling system does it, that as soon as it senses that the paint has the level of the paint has reduced, it would start to refill the paint. So this entire the entire factory floor has these radiators of the cars. The radiators come on a belt, they get lowered into the paint, and they get dipped in the paint for they remain dipped in the paint for some time, and then they are pulled out. Okay, so as the radiators move from this side to the other, they get painted. Okay, and there is this tank in which there is paint. The radiators dip into this tank, and that is how the painting process happens. Now, if I want to do component analysis, okay, so why am I talking about this engineering system? There is a problem. The problem that this manufacturer was facing was, it's a very simple way to paint the radiators. The only problem that this guy was facing was that, you see, there is this float here. So all of us would have some water tanks on our roofs, on the roofs of our houses. How many of you have gone and cleaned those water tanks ever? Or even just opened them and checked them out ever?
So I've checked them maybe once or twice, but
yeah, you've seen them, huh? Okay.
Yes.
Anyone who's not seen them ever? Never opened this water tank? पता नहीं पानी जादू से हमारे टैप्स में आ जाता है. Anyone of that kind category here yet? No, there's no problem. I'm just checking if I introduce these floats in a particular way, will you understand or not? So if you have seen those tanks, so all of you have seen those tanks, what do you see? There is a ball there. Huh? At the end of the ball, there's a ball and there is a lever. And as the water level rises, this lever goes up, like it goes like this and closes the tap. So your water tank doesn't overflow. Have you seen that? The ball inside your water tank?
Yes.
Huh? So the same system they had applied in this place also. They said we will have a float. This float would rise as the level of the paint rises. Huh? So as the level of the paint rises from, say, this level to this level, the float would also rise. And as the float rises, I have kept a lever there, which will turn off the switch here. Now, what happens is, over time, this float starts to get paint solidified on it. So paint is usually thick, and when it interacts with air, it would solidify. So when such a thing happens, the float becomes heavy. The float becomes heavy means it will not rise as much as it used to when it was light. And in the process, paint overflows from this tank. When the paint overflows, there's a big problem. The problem is that the shaft floor has to be, the production has to be stopped. The shaft floor has to be cleaned. There is paint all over the place. You have to also use additional material. So there is additional cost. So there is loss in multiple ways. First, your production stopped, so time loss. Then, the system needs to be cleaned up. Everything needs to be cleaned up. Material lost. More labor needs to be invested. So many things. So there's losses, and it's not desirable. Especially the production, stopping the production is definitely not desirable. So this problem needs to be solved. But to solve this problem, the first thing that we need to do is component analysis. So we list down what are the components of this engineering system. So this is the problem that I just explained to you. And we want to solve this problem, but the factory owner said that I do not want complex approaches. I do not want to use sensors because of high cost and so on. somehow improve this system so that with minimum changes, I'm able to work. So this is our paint filling system in a little zoomed fashion. And if I do the component analysis, the engineering system is paint filling system. The components of this system are float, lever, switch, motor, pump, and barrel. And what are the super system components? Paint. When you brought the engineering system, paint did not come with it. You filled the paint. The paint is a super system component. The tank did not come with it. I'm just talking about float, lever, something to switch off the motor there, something to stop pumping more paint into the tank. Paint, tank, the radiators, air and gravity, they are not specific that you manufacture and you gave to your customer there. So they are the super system components. Let's look at another example. Hair dryer. Many of you may have used a hair dryer, seen a hair dryer at your home. So what are the components here? So when you look at it, you say that the components, the engineering system is hair dryer, and components I'm looking at are body, power cord, heating element, fan, nozzle, motor, handle. What are the super system components? Air, user who holds the hair dryer in his or her hand. Water, because water is what needs to be removed. And here, they did not come with the hair dryer. You had your hair with you when you went and purchased the hair dryer. So here is also super system component. You could list down many more super system components also, but these are the most relevant ones. Are you able to see this?
Yes, sir.
Any questions? Great. So